Kitchen Table Astronomy with Hampshire College astronomer Dr. Salman Hameed, Mr. Universe here in Amherst. When I was in 7th grade, I had a great idea that I was going to do my science project on phrenology, which is the study of feeling people's heads to try to tell different traits about them. And then my science teacher, to their credit, was saying, this is discredited as a scientific endeavor. You may not do phrenology as your science project. You were in a similar, but definitely more scientific conundrum when you were wanting to study gamma rays for your thesis. Gamma rays, what are they and why are they cool?
Well, gamma rays themselves are just sort of like form of light, but the high energy, sort of like higher than X-rays, for example. But what I wanted to study were gamma ray bursts. And this actually sounds cool. And it is cool. This is one of those cases where hey, gamma ray bursts, and it is really cool. But here is the story. So this year, in fact, June of 2023 marks the 50th anniversary when a paper came out, and that is 1973. By the way, and I was very little at that time, so this story is not related to at that time. But in 1973, a paper came out that said that US spy satellites had detected some gamma ray bursts whose origins we don't know. And we have no clue what they are. And so just to back up a little, in the 1960s, the US and Soviet Union at that time had signed a nuclear test ban treaty. I think that was 63 or something like that. And well, it's great to sign a treaty, but then you have to check if that is being sort of being followed through or not. So US had some Vela satellites. Those were detecting whether Soviet Union is violating the test ban treaty or not. And when you test a nuclear bomb, you emit gamma rays. So this was meant to detect gamma rays from the Earth. They did not detect any. But in 1967, I think it was Vela 3 and Vela 4, they started detecting gamma ray bursts, but those were not from the Earth. And so, and in fact, so obviously, as you can imagine, initially it was like, well, are they from the Earth? You could not isolate closely where exactly they're coming from, but enough to say, not from the Earth, from space.
Good thing, because it could have started a nuclear war if they were getting these tests of gamma ray bursts and then saying, oh, the Soviets are doing it.
Sure. And so by the time, so they kept on detecting those, and they had no clue what it was. And then in 1973, it became more public. I mean, from what I knew at that time, I thought that those were classified. It wasn't classified, but it wasn't public information either. But in 1973, a paper got published in an astronomical journal that said, hey, we have detected a few hundred of these, or maybe it's a 73 at that time, 75, a few of those gamma ray bursts. We have no clue what those are. All we can say is that this is not coming from the Earth. It's coming from somewhere else. But what are those? We had no idea. And up in the 90s, so I was doing my undergraduate at the time in the early 1990s, and the nature of gamma ray bursts was still completely unclear. Now, a new satellite went up. It was called Compton Gamma Ray Observatory. So this was actually one of the 4 great observatories. So you have Hubble Space Telescope, which everybody knows, but there's a Chandra Space Telescope, and there is also Spitzer Space Telescope. So Compton Gamma Ray Observatory was one of those that was launched, I think, in 92, and it was considered that it's going to immediately solve the gamma ray problem. Right? So just think about it for a second. I mean, again, how science works. We are detecting these gamma ray bursts, but we don't know what they are. All we see is, boom, there is a burst in gamma rays. If you have a gamma ray telescope, it's going to see. We knew that they last a few seconds or a few tens of seconds. That's about it. So, by the way,
that was the dog sneezing. Bless you, Wookie.
And so these, only what astronomers knew was that there are some gamma ray bursts that last less than 2 seconds, and there are others that can last longer than 2 seconds, but maybe a few tens of seconds, maybe a few minutes. What are those? Those are the only things that we knew. So one thing you can do is to figure out, if you look up in the sky, where are they distributed? If they are coming from our own galaxy, then just like if you look up in the night sky and you see the distribution of stars, stars are not everywhere. But in fact, you would find a higher concentration of stars in the disk, which is called Milky Way, because that is the Milky Way galaxy, more of the stars are there. So one idea was that, well, if we look at the distribution of these gamma ray bursts, if they follow sort of like this disk-like distribution, then they're coming from something that is in the Milky Way galaxy. But what astronomers found when they detected with Compton Gamma Ray Observatory, actually they detected about a few thousand, 3,000 or so gamma ray bursts roughly, and they were distributed everywhere, isotropically. Okay, so what does that mean? Well, either they are very close, so meaning to say maybe they are solar system objects, maybe something going on with comets or something like that, so we see a spherical distribution rather than following the Milky Way, or they are so far away that we see them distributed all over the universe. But then what that implies is, if we are detecting them, they're really energetic, and we did not know if there can be any objects that can produce such high energy objects, because if they are located billions of light years away. So two very different ideas. They're very close, so they don't require as much energy and we are detecting them, or really far away. And that's where, Monte, the thesis question or the undergraduate question comes in. I did my undergraduate thesis on gamma ray bursts, and my hunch was, and it was a hunch because we didn't really know, that they are billions of light years away because it's cool. Whatever those are, they're coming from far away, but we didn't know. And there were over 100 theoretical models. so theoretical astronomers or theoreticians or physicists were having a field day because we didn't know what they were. Hey, how about we throw this thing that can produce gamma ray? Sure, right? And but I remember I went to grad school, and because my undergraduate thesis were in gamma ray bursts, and so I was put into that track. But then I chickened out because I was like, man, those are two very different things. If they are solar system objects, or if they are billions of light years away, and one of those groups is going to turn out to be completely wrong.
And if you're doing your thesis on the completely wrong one, that's a lot of work for naught.
Yeah, so I chickened out. It shouldn't be the case, but I did chicken out.
I didn't do my science fair project on phrenology. I did it on male pattern baldness, because even in 7th grade, I knew that genetically I would lose my hair almost guaranteed, but I thought I would delve into it more scientifically, and my theory was correct. Well, I don't have hair.
Well, that's okay. So that's great, but I chickened out. I wasn't sure about the baldness bit, so I was like, I'll stick with.
Head of hair then.
So, but in 1997, so the idea was that you have to get some other information other than gamma rays. The mystery was, all you see is this burst, this sudden burst, very short-lived, but only in gamma rays. But it must be in some other light. And it was very hard to follow up because they just go out, they go back to faint, sort of within a few seconds. So the question was, can we find some follow-up observations in some other light? And that happened in 1997. There was a satellite called BeppoSax. It was an Italian X-ray satellite, and it finally detected a follow-up. And it could narrow down. The other problem with gamma ray bursts was that you could not narrow down in the sky to really tiny region, because the resolution or whatever the gamma ray is, the way we could only tell it's roughly in this direction, but in that direction there could be galaxies, there could be stars, and so on and so forth. But BeppoSax could narrow it down, and they found that there was a fuzzy patch around this gamma ray burst, which was found in X-rays, and later on they started finding in optical or visual light as well, and then you could find it sort of fade away, and that was associated with a galaxy. And so that clinched the case that these are not part of the solar system, but in fact these are associated with galaxies billions of light years away.
So you would have been right.
I would have been right, yeah, but I mean, but it could have been wrong too. and trust me, there were people who turned out to be completely wrong. So this is a beautiful example of sort of things that we didn't know, looked really cool, but today we don't talk about the theory that would turn out to be completely wrong. In fact, now we talk about various types of gamma ray bursts and what we know about them, which is very cool.
Why do these gamma ray bursts happen?
Oh, great question, Monte. So this is, as I mentioned, if they are billions of light years away, then they must be one of the most energetic events in the universe. And what astronomers found was that this is not just a supernova. So supernova happens when a star that is bigger than our sun, 10 times, 20 times, when it explodes. It ends its life, it goes into a supernova, and for a brief period of time, the brightness of a star outshines the entire galaxy. And it lasts for a few weeks in that brightness. And our sun is not going to become supernova, but we know the stars exist that are bigger than that, and that's what happens. Gamma ray bursts are produced by stars that are even bigger than that. And when they die, it's called a hypernova. And it's not even supernova.
Wow,
hypernova. They can be a million times brighter than the supernova. And what happens is that the star is turning into a black hole. And what happens is that the material, when it collapses, going close to the black hole, it turns into two jets. And so we have talked about it before, sort of like, the black holes actually not inside the event horizon, but outside of it, you can have accretion disk. That's what was sort of like, seen in through telescopes and things like that, material surrounding the black hole. And because of the material just falling into the event horizon, right before that, the magnetic fields and the gravity is so fast that actually the material funnels into jets because of high magnetic fields, and those jets can be hundreds of light years big. In this particular case, that's what the astronomers think. What happens is that the star is collapsing into a black hole, but as it is collapsing, as it is forming into a black hole, some of the material forms into these jets, and they are ejected, a lot of it in gamma rays. Now, if you happen to be looking in the direction of that jet, you are going to see a gamma ray burst. And it lasts for example, these are the longer gamma ray bursts, like 2 seconds to 100 seconds, or maybe a few minutes or so. That's what they are. So you have to be aligned in a way that the jet is facing the Earth and in that direction. So that's what we know, that's what happens. The very short ones, as it turns out, not hypernova. Those are colliding neutron stars. And those are so this is even shorter than that, few milliseconds to 2 seconds or so. And that's where we know neutron stars, these are sort of like the leftover remnants for really big stars, and they orbit each other sometimes because if they're two binary stars. And when they merge together, it's a very high energetic event, and they emit gamma ray bursts right before turning into a black hole, or if it's a neutron star or a black hole. How do we know that? Gravitational waves. So that's what we know, the LIGO, the gravitational wave detector that detected those things. So again, and we know that gamma ray bursts are associated with those as well. So these are some of the craziest explosions, craziest things, and we now know that they are associated with those.
It's amazing that these things are collapsing and colliding in the universe all the time, and that once in a while we're lucky enough to figure it out or to observe it, and then it takes us that long to figure out what's actually going on.
It doesn't even have to be once in a while because the universe is so big.
Right.
So you can almost detect sort of like gamma ray burst a day because the universe is so big, and so that so that they align. And occasionally, so there was one in I think 2008 where this was a huge gamma ray burst, and it lasted for about 30 seconds, and it was visible if you were looking up in the sky. Okay, I mean, it would be pretty faint, but it was visible in sort of like, a visible part of the spectrum, sort of like, your naked eye. You could have seen it, something pop up for about 30 seconds. Very faint. I mean, if you were in a dark space and like sort of like the moon wasn't there, so and so forth. But it was one of the largest gamma ray bursts ever observed. And it turns out it was 7.5 billion with a B light years away. I mean, in some sense, just think about it. Our eyes can see faint objects like sort of like Andromeda galaxy. That's about 2 million light years away. That's the faintest that we can see, just unaided with anything. And here you would have been able to see this gamma ray burst 7.5 billion light years away. And then just in last year, there was another gamma ray burst, which is now dubbed as, sometimes astronomers come up with these names like, go like, whoa, now credit to them.
Okay.
And it was called the Boat, the brightest of all time.
It's the Tom Brady of gamma rays.
That's right. And so that actually lasted. It was an unusual one because it lasted a few hours, and this was coming from about 2.5 billion light years away. And there is just last week or last few weeks, there have been other studies that have come out, and they find sort of like that this was a very unusual one, that the jet actually brought in. It wasn't just a narrow jet, but rather it has some star material also being funneled in, and so on and so forth. So because it's relatively close by, 2.5 billion light years away, they think that this is a great laboratory to actually start to understand what these bursts are. The part of the problem is that they're all so different. Like they're not identical. So that's so we know those things. But I think that the next question that comes in, what if it happens close to the Earth?
Yeah.
We don't have to worry about it because these gamma ray bursts, even though I'm talking about jets pointing towards the Earth and their gamma rays, they are quite far away. But if they were in the Milky Way galaxy, say, for example, 5,000, 10,000 light years away, which we do have some stars that are really big that can go that can produce gamma ray bursts if you are in that direction. That may be a little bit of a problem.
What would it do to us?
Well, so some people have studied the potential if there was a gamma ray burst about, say, 5,000 light years away, kind of sort of like the ones that we've been talking about, they think that if it is pointing towards the Earth, that jet, they think that it's going to really damage the ozone layer.
Wow.
And they think that a few sort of like 30% or 40% ozone layer is going to get damaged, and that would lead to a lot of ultraviolet light coming down to the Earth and leading to sort of like extinction of some animals, and for humans, of course, cancer and all of that stuff that comes in. So it's not the Hollywood scene where we are going to be obliterated, evaporated. No, it's going to be a little bit slower. But and some people think that there have been mass extinctions. Of course, we know there have been multiple mass extinctions. The one that killed the dinosaurs was by asteroid or a comet, or and so on and so forth. But they think that statistically, there might be one of the mass extinctions in the history of the Earth may have been by a gamma ray burst happening, or a hypernova happening in the Milky Way galaxy. And they point to, I've read a little bit about it. I'm not a biologist, so now I'm just like, but they think that the mass extinction that happened 450 million years ago, they think it might have been that, partly because the trilobites, those little critters, they actually survived it, and they think that because they were under the water, because they sort of plankton and so they think that one maybe, but it's very, very hard to pin blame on that. Nevertheless, if something like this happens, like the one, that 2008 one, that was visible barely to the naked eye, even though it was 7.5 billion light years away, if it happened about 10,000 light years away, it would be as bright as the sun. So if it was at nighttime, you would suddenly have another sun appear for a few seconds. And that's just crazy.
And then the slow process towards our inevitable extinction would begin.
That's right. But again...
something to look forward to.
But again, it happens very rarely. And also, you have to be just unlucky enough to be in the sort of in the zone of its beam, or the direction of the jet. But hey, and again, I would say, Monte, we have talked about it. Everybody's gonna go. We're gonna go. The Earth is going to go. The sun is going to go. Wouldn't it be cool to go sort of being sort of hey, yeah, well, we went because we just happened to be in the sort of in the direction of the gamma ray jet. that was coming out of a star that exploded and was turning into a black hole, and it just happened to be pointing to the Earth, and that's why we got extinct. I think that's a great story to tell.
And then you could be like, hey, I studied those in college. I was like into this way before you all.